Okay, welcome everyone. Welcome to the Education Platform session. My name is Cécile Pereire. I'm from Carnegie Mellon University and I will be your chair. All the papers during this session are from the SEED track, Education and Training, but we'll have a variety of different types of paper. We'll have one research paper, one replication paper, two tools paper, and an experience report. You probably know the rules of the session by now, but let me repeat it to you. So we are going to have 5 short presentations, one after the other, 5 minutes each, with no question in between presentation, and we'll keep all our questions for the discussion at the end after all the presentations. And to make it more interactive, I will ask all of you to contribute questions, and I will ask you to use the chat to write your question down and prefix your question with the name of the presenter. Like if I want to ask a question to Madeline, I will write @Madeline in the chat and I will put my question, and I will ask the presenter, Madeline, and all of them not to answer directly in the chat, but to keep the answer for the interactive discussion at the end. Does that make sense? Are there any questions before we get started? No? Okay, it looks like we're ready. So our first paper is a research paper. It's called Debugging with Stack Overflow, Web Search Behavior in Novice and Expert Programmers, and it will be presented by Madeline Andrus for University of Michigan.
Hi, can everyone hear me?
I'm really looking forward to the session. So I'm going to start today with talking about our paper, Debugging with Stack Overflow, in which we compare how novice and expert programmers use Google search to find help out online. Okay, so to start out, finding debugging help online can be challenging, especially for novices. To see how this could be the case, let's take a look at 2 different programmers who are faced with the same buggy Python program. Both programmers are unable to fix the program on their own, so they turn to Stack Overflow for help. Our first programmer is a C expert, but they're new to Python. When searching for online help, they paste parts of the error message and add programming keywords and jump around in the Google search results. This strategy is successful, and they find a helpful post on their third search, correctly fixing the error. Programmer 2, however, is a true programming novice. They also search the web to try and find help. However, unlike Programmer 1, they do not copy portions of the error message, use general language, and always click the first search result. After the 4th search, Programmer 2 also finds a post that they think is helpful. However, the key word here is think, because this post doesn't actually contain relevant debugging information, and they do not correctly fix the error. So this interaction was adapted from a real one that we saw in our study, and it really motivates our investigation in this paper into understanding the relationship between different types of programming experience and Stack Overflow searchability. Our results from the study could inform developer training for improving Google code search and also help researchers design future tools that support online search. So to investigate this, we conducted a human study with 40 participants, of them using Stack Overflow to debug different Python programs. Participants were divided by experience level. We had programming novices, programming experts with little to no Python experience, and then experts who were both experts in programming in general and also in Python. Participants were shown a set of Python bugs. For each bug, participants had 10 minutes to try and find a helpful Stack Overflow post. These debugging sessions were recorded and annotated by multiple authors for analysis. Okay, so with that, let's get to our main result. Does programming experience correlate with the ability of programmers to find helpful Stack Overflow posts? So the answer is yes. Python familiar experts are much more likely to be able to find relevant posts, followed by non-Python familiar experts. Novices are the least likely to be able to find a helpful post. This difference is significant and has a moderate effect size. Overall, this finding shows that novices improve their Stack Overflow search skills over time. Additionally, as programming experts who know Python outperform experts who do not, it may be that even language-agnostic Google Code Search training could be helpful for novices who are learning how to program. Beyond our main result, we also find additional relations with how easy it is to find helpful debugging information on Stack Overflow. If you are interested in the details, definitely check it out in our paper. However, here are some of the highlights. First of all, we find that some browsing behavior features correlate with Stack Overflow search efficacy. For example, experts tend to click more search results further down the page than do novices. Additionally, a bug's error type may relate to the ability to find helpful information on Stack Overflow. For example, some error types are both easy to find a relevant post for and easy to fix, while others have a high rate of finding a relevant Stack Overflow post even though the error is often challenging. Still others, such as syntax errors, are both hard to find relevant posts for and also easy to fix. Altogether, these error-related results can help in the design of future code search training. For example, teachers could encourage Stack Overflow use for those error types that it is most helpful. Our results may also impact future automated tools. Just as humans find some errors easier to debug using Stack Overflow, the same may be true of automated tools based on mined user data. Future tools may want to focus on error types where they have the highest chance of finding helpful information. So with that, I'm going to conclude. In this paper, we ran a human study to understand the impact of programming expertise on Stack Overflow searchability. We found that both language-specific and general programming experience do correlate with search efficacy, and both are kind of needed to be really, really efficient at it. Additionally, we found correlations between various features of, say, code search or bug type with the likelihood of finding help online. Our results provide evidence for the design of future Google code search training and automated tools. Our replication package is available online, and also I'm looking for research internships in 2023, so if you'd be interested in talking more, definitely let me know. Thank you, and yeah, thank you.
Thank you, Madeline. Thank you. Great timing. Perfect. Okay. Yes. Clap, clap, clap. Okay. Let's move on to our next paper. It's a replication paper. Bhuvana, are you ready? Or do you need more time to figure out things? Or are you ready to present now? Could you just try your mic?
Well, I text her, but there's no reply and no response.
Okay, so I'll let you continue a little bit.
Are we allowed to ask questions here?
Oh, you're here, so you can talk. Very good. No. You're not supposed to ask questions here.
Or do we need to type the questions out? Can we ask them here?
No, type the questions. But could you hear us?
Could you hear us?
Yes, I can hear you guys. Can you hear us? Can you hear me?
Yeah. Yes. Perfect.
Okay.
So
Bhuvana, I had a question. Can you speak a little bit more to the
No, we're
other
not
academic preparation or other kind of programming abilities that these, Python experts had?
So Bhuvana, we're not answering question now, but it's your turn to present.
Oh, okay. Sorry.
No, that's totally fine. So are you ready to present? You can share your screen and you have 5 minutes. And you can type your question after the fact. Very good. Thank you, Wesley, making a note of the question. No worries. Totally fine. Go ahead, share your screen and you can, Bhuvana, and you can get started.
Is there some issues with the screen sharing?
I don't know. You know what, Jawan, why don't you work things out beyond the scene and we're going to move to the next paper. Unless, Bhuvana, you're ready to start right away.
Where is my share screen button? I'm trying to find it.
On the left corner, there's a start sharing screen.
Yes. Okay, great. Window. There we go. Share.
Okay, so Bhuvana is going to present.
Hi, everyone. My name is Bhuvana Gopal, and our work that I'm presenting today is about this active learning pedagogy called Peer Instruction in an online software testing and continuous integration topic. It's a replication study where we replicated our previous work that was done in person, and we did this in a completely online Zoom-based setting. So our main research questions were just to see if peer instruction helped our students learn unit testing, integration testing, and continuous integration better than students in an equivalent online lecture, purely lecture format class, and whether it did not only increase cognitive abilities to understand these topics, but did it increase their enjoyment of students in learning these topics. So the original study was in person. We had a bunch of different majors of students, computing majors and some business majors as well, and some electrical and other engineering majors. But the replication study was fully synchronous and online, and it was for CS or CE majors only, and not honor students. There's a little bit of detail here on the student distribution. We grouped our students into two different groups: the treatment group, which was the group that underwent peer instruction in an online setting, and the control group that underwent lectures in an online setting. There were some differences in the ways sophomores, juniors, seniors by college standing were distributed, and we took that into account while doing our analysis. So as far as methods go, we used a pre-test, post-test hybrid between groups and within groups survey. We did the treatment a particular year and then the control the year after that. We utilized two instruments: a cognitive questionnaire that had 16 questions with unit testing, integration testing, and continuous integration that we created, and then an affective questionnaire where we used a standardized instrument from Moscal and Hegg. It had 5 different constructs that we tried to measure a shift in whether students had a shift in any of these constructs: confidence, interest, gender, usefulness, and professionalism. So here's an example of one of those cognitive questions that I spoke about here in the cognitive questionnaire. How does the single responsibility principle affect testability? Another question would be, what are some common reasons why a build might hang? So this was what we were trying to get at. We had Zoom sessions for the treatment group and the control group alike, except that in the treatment group, they had peer instruction built in, which was a mini lecture with peer instruction cycles. We had the first vote followed by a breakout session with groups, and a second vote. I describe all the details in the paper, and then an instructor-led discussion. So both groups were administered the cognitive pretest and an affective pretest, and then went through the actual class, either with the intervention of peer instruction or not, and then they had the cognitive and affective post-tests. So here are some numbers showing our student correctness percentages, and this is the within groups approach that we talked about, pre and post TG, and across groups would be post TG to post CG. And I will show you that the numbers that we analyzed with ANOVA techniques brought us to these results. So 41% more students in the post test gained correctness compared in the pure instruction group compared to the lecture group. Similarly, in integration testing, the gains were even more pronounced, and continuous integration had very large numbers of students doing well. And when we put them through a statistical significance lens, we found that within groups, pre versus post-treatment, within the treatment group, we had statistically significant increases. And across groups, between the control and treatment groups, we had statistically significant increases and no real statistical significance when we compared the other groups. This is actually encouraging because it tells us that students started out not very dissimilarly, but then based on the intervention, they ended up in significantly different places. So some of the limitations of the study, we think, are the fact that there was no physical presence and all online, and we are not quite sure what those effects might be, and also what industry internships might have been and what the effect of that might have been with students. So we intend to look at some of these things, look at internships, look at how we can use this for remedial education, what specifically were the online environment's role in attaining these cognitive and affective gains, and things like that. And thank you very much and that's my time. I'm happy to take questions at the end whenever it's time for it.
Very good. Thank you so much, Bhuvana. Very good. Clap, clap, clap. So we'll go to our next paper, which is a tool paper called CRS, a hybrid course recommendation system for software engineering education. And it will be presented by Quant Vu, from RMIT University, Vietnam.
So I start to share my screen now.
Yes, and just to tell you that the name on Quang video is Ni, which is the name of his co-author. So when asking question, you can say Ni/Quang or whatever. One or the other will work. We'll know it's a question for you, Quang. Mm-hmm.
Okay. So can you guys see my screen?
Yes, we can.
Okay. Hi everyone, welcome to our presentation. Our research was led by Dr. Yi Võ and other authors including Nam, Tu, Quang, and Bang. Our research topic is to build a hybrid course recommendation system for students and staff in software engineering. So let's first talk about the problem. A lot of universities enter their freshman year without knowing what they want to do in the future. They neither have no idea what career they want to follow or struggle to find out the necessary skill set and how to acquire them for their future dream job. So with that motivation, we designed our own recommendation system for students and staff in IT industry. The system consists of 5 main components. First, we have a system which automatically connects the data from the website. The data then passed into a name entity recognition model to extract the relevant programming skill keywords. The keyword will be used to make the recommendations to our users. We have the website to allow the user to interact with our system, and finally conduct the user survey to gather the feedback. So to put everything together, we first build the automatic system to connect the data from 3 different sources. We got the job information from job posting sites, the university courses information from their websites, and some online learning extra material from online learning platform. This data will be stored in the MongoDB database. For the web application, we deploy it in Firebase and Heroku. User will send the request to receive the JSON WebSocket to access APIs for our recommendation system. So this is a summary of our hybrid recommendation system architecture. At the beginning, we build the context-aware model to the top first. We extract the keyword provided by our CSIT domain-specific NER model. We then combine with the dictionary built from MC API to calculate the similarity score between our items to suggest the items to our users. We build the second model, which is the collaborative filtering based on the user interactions, user profile, and user ratings from the survey. Then we use it to train the restricted motion machine, which can predict user preference and the background and behaviors. Based on this preference, our system would provide different recommendations for each user. These recommendations are combined with the context-aware model and get passed into the hybridization layer to produce the final result. Let's go to the overview of the feature of our website application. So the website application is split into the user side and admin side to fulfill the user needs and improve the security. User can also get recommendations for university courses, career options, and skill set analysis. User can change the profile into different roles, teacher and student, to have more suitable analysis and recommendation for different roles. For the admin account, management dashboard, insights detail, and data versioning control are the main functions. So we highly recommend you to watch our demo video to see some feature in action. I will send in the chat later on. And for the survey we conduct, so for the first 4 questions, we assess the performance of our recommendation system. For example, how useful the system is. The rating is from 1 to 5, with 5 being the most positive. The remaining 4 questions assess the UX and UI design of the website. We ask the user to rate it based on the navigation, response time, and UI design of the system. So to further validate the survey responses, we conduct the statistical testing on the result. We perform a normality test, which show that our response did not follow the Gaussian distribution at 99% confidence level. So we proceed with non-parametric test, the Kurzweil age test and the Friedman test. We split the user into 2 different ways, depending on the user expertise level and user career interest. The test provides that the different groups of users had different answers and ratings for our system. This indicates that we have obtained quite good data sample with many options from users. So for the future work, we tend to integrate this into another system of university, and then we revamp the UX UI to have better experience of user. And the wrapping recommendation system, we will expand the university and the careers coverage. Finally, we include more online materials such as books, research papers, and tutorials, which can help to diverse our recommendation to our users. So this is the end of our presentation, and thank you very much.
Okay, thank you so much. Okay, let's move on to our second tool paper, which is ETSS, Interactive Web-Based Authoring and Playback Integrated Environment for Programming Tutorials. And the paper will be presented by Heng Lee Hu from the Singapore Management University.
Okay, let me share my screen. Can you see my screen?
Yes, we can.
Yeah.
Thank you.
Okay, so this part is on our implementation of a tool, interactive web-based for authors and for students to learn programming based on the programming tutorials. So some motivations and challenges. I believe when we start to learn, or for novice programmers start to learn programming, one of the tool or one of the resource they will look at is the video tutorials. Instructors will record videos like this where you will demonstrate the concepts and the coding, and they can rewind forward and even annotate on the videos to learn. However, the streaming nature of the programming tutorials, those traditional videos, has quite limited interactivity. So beside adjusting the timeline, looking at the different parts of the video, they can't really interact with the contents, cannot copy the codes, cannot really go into what the authors has been doing directly during the video recording. There are existing works that with increased interactivity, where they record and track the author's movement and contextual events and play back to the students, and shown to help students' learning experience. However, this approach, or in these studies, it requires custom installation by the authors and by the students to play back. And it can be quite intrusive because it actually uses operating systems level accessibility APIs. So this tool itself was being inspired by existing works, and we try to improve it with a web-based system with the increased interactivity. This is a screenshot of the ITSS tool itself for the students to play back a video. This screen is actually quite similar to an author's screen, where the authors will have a record button, but the students will not have. What's different from a traditional video as per the tool is, this is not, when you play back to the students, it's not playing frame by frame. It's not playing by screen by screen, but it's actually replaying keystrokes and the actions of the authors directly on the browser. And the students still can forward and backwards rewind and adjust along the timeline. The student can even copy the codes, copy the text of the programming, copy the codes, and can even practice coding on the screen directly. Another feature that we built in for the authors on our tool is they can actually adjust or create sections of the tutorial. So instead of having one big tutorial of 20 minutes, they can mix and match different sections together, adjust the sequence before they release to the students. One thing I want to also mention is for the students' screen, they can also use the search button to search Stack Overflow or other online resources based on the exact contextual or context of this programming tutorial. Okay. So some of our benefit of the way that we did is, now for the video that is recorded, it's become a text artifacts, and the authors can modify separately without even re-recording the whole thing. They can actually modify the text artifacts directly. We can do the search accurately based on the text-based artifacts without reverse engineering from the video frames. And with the text-based artifacts, now we can provide context-specific assistance based on the exact tutorial topic. the error that you discover and provide more context-specific assistance. And with this tool itself, the data size is actually much smaller. That means the video that is actually played onto the student screen, the traffic, the network's data size, everything will be smaller than the recorded video. We did 3 different evaluation. I will show 2 of them. One of the evaluation is on the author side. Do they think that it's easier to record a programming tutorial? We have 20 participants. We invited 20 participants actually join in, and all of them either agree or fully agree that it's much easier to record a programming tutorial on the web base with the increased interactivity. And we did a survey, or we did another survey based on the system usability scale. We managed to achieve 73%, which is based on the scale is considered very good, but there are definitely other areas that we need to improve on. One of the things that we also wanted to discover from the authors is what are the different features, so that is very useful for them when they do authoring of programming tutorials. I think the best part of that is they're able to write code and execute the code directly on the browser, and they can replay back to the students. One of the interesting findings is recording of face is actually not very useful. There's quite a balanced view of whether is it going to be useful, whether you record the face of the authors. On the student side, 72% actually agree or fully agree that it helped them to learn programming better. There's about 20% who has not really a preference, partly because looking at the comments, they really hope that there is another feature to speed up the audio or to speed up the video. So in the future work, we actually enhance the systems with a way to actually speed up along the timeline. For the system usability scale is around 73%, which is similar to authors. And the types of features they prefer is also quite similar to the author side, especially on the author's code to practice and authors on highlighting of words. This is, they actually greatly prefer that. So in summary, this tool itself, we presented integrated, extendable, and scalable environment to author and playback of programming tutorials. And this novel approach actually helps to actually capture and playback the author's interactive actions without custom installation on the author side or on the student side. And we evaluate the findings of both the authors and the students' way of whether they find it more useful and more easy to do it. That's it. If you have any questions, can actually email me. And we have a GitHub link where our source code are open source, where both the students and authors' source codes are available. Thank you.
Thank you. Very good. Thank you. So let's continue with our last presenter. It's going to be Carl Hildebrandt from University of Virginia. He's going to present an experience report called Preparing Software Engineers to Develop Robot Systems.
Let me see if I can share. Can you see my screen?
You're good.
Perfect. Thank you. All right. So hi, and thank you for coming to our talk on preparing software engineers to develop robot systems. Before we begin, if there's one takeaway from this talk, it's that everything we spoke about today can be found on the class website on this QR code shown up. So let's begin. Robotics as a field has grown steadily over the last 2 decades. Even with all this, the robotics industry is still projected to grow by 25% between 2020 and 2025. So how are we preparing to fill the need for engineers capable of allowing such development? To fill this gap, several curriculums have been developed, and in general, we can fit these curriculums into one of 4 categories. There are specialized that generally focus on specific elements of the robotic system. However, they tend to overlook the fact that robotics heavily relies on software. Next, there are cyber-physical or embedded system courses, which tend to focus on particular aspects of the robotic system pipeline. Then there are massive open online courses that scale up the number of students introduced to these topics. However, they aim for a breadth of student applicants, meaning graduates may lack in other fundamental software engineering principles. And finally, we have traditional software engineering courses, which fail to handle aspects specific to robotic systems. With this in mind, we set out about creating a new course, Our goal was to develop a course that would enable upper-level undergraduate students to gain expertise on foundational aspects of software development for robotics. Specifically, we wanted to develop a course that introduces students to robotics while reinforcing the principles of software engineering to better prepare students to develop these systems. To achieve this goal and develop the course, we came up with 5 guiding principles, which resulted in a set of innovations. But due to time constraints, we don't have time to discuss them in this talk, but we highly encourage anyone interested to take a look at either our paper or longer talk. To get a sense of this course, let's take a look at an example of both an example lecture and lab, starting with the lecture. The aim of this lecture is to introduce the fundamental concepts related to robotics architecture, robotics state, and environment. We start by highlighting how cyber systems differ from robotic systems. We then dig a little deeper and talk about what are the typical states in a robotic system and the different parts of the robotic systems, for example, path planning and perception. We again go even deeper and start discussing domain-specific architectures, for example, probabilistic versus. We then talk about how to realize these systems and discuss different trade-offs between different realizations. And finally, we dive even deeper and start discussing how we would actually implement this using code, for example, using finite state machines to represent the different states we learned about. Next, let's take a look at an example lab. The lab starts by highlighting how what we learned in class can be used to implement real systems. We then ask students to implement a basic 2-state finite state machine. This allows students to start feeling more comfortable with the concepts taught in the lecture while not becoming overwhelmed. We then highlight how students can debug their code. This allows students to self-debug their finite state machines, making sure it works as intended while learning good debugging principles. We then use checkpoints to allow students to reflect as well as discuss what they have done with either of their instructors or the teaching assistants. We then emphasize how certain design attributes should be parameterizable and how students should design code to be easily reusable. With this in mind, we ask the students to add additional states to their finite state machine, and this is done so that we can verify input given to the drone simulation, which is what the students use. And the verification is done using parameterizable constraints, allowing students again to do flexibility. And finally, we showcase how testing can be done through simulation, and this is something that is extensively done in robotics. To increase the students' breadth and perspective, 2 additional issues were focused on during the course. First, the course is aimed at upper-level undergraduate students, and thus many are starting to consider positions in industry. For this reason, we invited a guest speaker from industry to speak and interact with the class. Next, as robotics grows and becomes more apparent in all of our lives, there'll be several ethical questions that need answering and considering when developing the systems. We added a lab where students would debate over these issues. In retrospect, we discovered several things that worked well, as well as several things that need improvement. We will not discuss all of them now, but if we had to highlight one, it's that pairing software engineering topics with robotics concepts is extremely useful as students learn and reinforce both ideas, while we as educators can use one as a vessel to teach the other. However, on the downside, this requires constant updating as both fields are advancing rapidly. Overall, however, we feel like this course was a success. In the future, we aim to empirically test how successful this course was. However, we believe it is having impact. Last year, we had 26 students, and this year we have 75. Of last year's 26 students, 4 ended up in the robotics industry. And additionally, we had several students that emailed us and thanked us for how they actually use the concept learned in this course while talking with the companies that ended up hiring them. So in conclusion, we introduced a course aiming at equipping students with a unique understanding of challenges in developing the software underlying robotic systems and a set of tools to address those challenges. And with that, everything that I spoke about can be found on our class website. Thank you very much.
Great, thank you very much. Okay, so thank you very much to all the presenters actually for great presentations today. And now we're going to move to the next section of our session, which is our discussion. And I would like to start maybe with some question for Madeline, which is going to be represented by Wesley now, because we had a lot of questions for Madeline. So Wesley, you're going to be on, but who would like to ask a question for Madeline/Wesley? You can just unmute yourself and ask your question. We have plenty in the chat. Just go ahead and do that.
I'll jump ahead then.
Yes, please.
So I think I'm just scrolling up so I can get it. So this question was, I was hoping you would touch a little bit on in the talk, and I didn't see it in the talk, but in the paper, I think it was figure 2, where you actually talk about, if I remember correctly, it's got like bottom and then how many clicks or queries they did until they found the solution. I expected that experts would take fewer clicks to find a solution. However, and I quoted, you said that the results showed that Python experts tend to spend more time with each search query by clicking on more links further down the page. And I found that interesting, as intuitively I expected the opposite. And could you talk a little bit more on that and why that is?
Definitely. You've warmed my heart by asking this question. I should offer the disclaimer that that part was still more exploratory research compared to the rest of the paper, so we don't have a perfect answer, but there are two elaborations I would try to give. One is that for figure 2, my apologies, I'm not ready for screen sharing in the short term, but I'll just say it out loud. A novice on the left will often just visit one page in response to a query about an error message and then give up. The setting for this exercise was you're writing a Python program and it says, type error. You just copy that into Google or maybe add some words and what happens. And we see that the novices will do that. They'll go to the first response from Google. And then, and this is, more exploratory, but for various reasons, it could be things like imposter syndrome, not understanding the language vocabulary. Novices will often say, well, I couldn't understand the answer from Stack Overflow or it didn't help me. I'm just going to stop at that point. By contrast, at the other extreme, a 10-year expert would visit more than 2. And it's worth noting that it's not actually taking the expert twice as long. It's true that they're visiting more pages than the novice, but the total time was not 2x, even if they visit 2 different pages on Stack Overflow, because they comprehend each page faster. And it may be that in answering some of the other questions, I'll return to this, but one of the things we're interested in doing is trying to convince or train novices to do more of a breadth-first search rather than a depth-first one and be discouraged. The second elaboration I would give is that this is one of the places in our study where per language expertise really matters. Sometimes as professors, we really like to say, oh, if you've learned one language, learning the next one, it's just syntax. It's the concepts that really matter. And that can be true in many places, but we're finding that it might not be true for things like searching for syntax error help or querying Stack Overflow. And we found that this particular thing you're calling out, sort of the time spent or the number of queries they looked at, people who are experts in programming, but not experts in Python, were more likely to behave like Python novices and not, keep searching. We hypothesized based on, we recorded all of their interactions, went over the 60-minute videos from everyone. We hypothesized that some of this is related to a lack of familiarity with language-specific vocabulary. The particular quirks of Python syntax were one of the reasons that people got discouraged, even if they were familiar with other languages. So I admit that doesn't entirely answer your question, but one aspect is, it's not actually sort of twice as long. People are giving up earlier. And the other is that, unfortunately, this befalls even developers who are experts, but not experts in Python. Did that answer your question, or did I dodge too much?
No, thank you. That I think the key there was I assumed that 2 queries means 2 times the time. And as soon as you said that, I was like, that's true. When I'm going through something that I'm familiar with, I'm very quick to open something, be like, nope, wrong direction, and done. Whereas someone more novice, I imagine, spends a little bit more time. I still find it quite interesting, though, that, like you were saying, that experts that aren't experts at Python kind of exhibit similar behaviors to novices. I thought that was really interesting, though. So I'm sure there's something there. There's like a nugget there that seems very interesting.
Okay. I think, you also had a question for Wesley, right?
Yep. Yes. Thanks for your presentation. I was actually looking forward also to hear more on your recommendations to improve. If we are going to develop an automated Stack Overflow tool for debugging, what should be the things that we look out for novice programmers?
Thank you. I appreciate the question. It's true, we did not cover that in the short presentation. I have 3 things I would mention briefly to address that, and one will be a shout out to another researcher. One of the first lessons we found is that error type actually mattered quite a bit. When novices were searching, counterintuitively, it was actually very difficult for them to use Stack Overflow to address syntax errors And it was they were more likely to succeed for things like attribute errors or type errors. And so it may be that we want to target tool support, especially if it's built into the IDE. The tool can see the type of the error, that's occurring, and we might want to give more advice or more guidance for certain types of errors, and maybe not get in the way for others. So one would be to make it per error type specific. That also gives us more structure to exploit. The other is that we might consider mining certain Stack Overflow responses. There's been in other areas of software engineering research, there's been increasing interest in treating things like Stack Overflow as a data set that's available and applying natural language processing or predictive approaches or deep neural networks. And it may be that some of that is handy here, especially if we think that like in an 80-20 rule sense, that a lot of the benefit could be obtained by having novices conceptually look not just at the first answer, but at the second or third, some sort of natural language summarization that includes a little bit of information from each one. And then, if you like this second sentence, click here and go to the second link, might encourage novices to, to take that breadth first behavior. The other, and this is a bit more, sort of future looking, but I would bring to the attention of the audience the work of Danae Ford and others who have studied some of the social behaviors, how collaborative editing with mentors improves engagement in social Q&A communities. I really recommend her papers like that. And she was, at least in some of the early work, maybe looking at if there was someone else there, a human who was helping you or providing guidance, would that encourage you to stick around? And so a third answer I would give to your question is, we would take some of the behaviors that she and her colleagues had found to be effective in keeping people using Stack Overflow and getting answers. And I would say, could we make a tool that mimics some of that? If her research has found that experts that do X, Y, and Z, help keep novices around, could we have a tool approximate maybe X and Y? And so those would be my 3 quick answers.
Yeah.
Very good. Thank you. I think we need to move on to other papers now. Thank you, Wesley. You can maybe answer the other question in the chat.
Question I wanted to bring up.
Okay.
I know you addressed a little bit of this while answering Carl's question, but what was really, I think you mentioned experience with Python, right? Versus, having experiences with other programming languages and syntactical issues still being an issue. I wanted to make an observation. If you had the right IDE with some kind of a linting tool or something that did syntax checking or, style tool or something like that, for example, Visual Studio, you can have ReSharper that'll for sure, give you syntax issues if you start out with, and things like that. That might actually eliminate the Stack Overflow, component there, which could have been, dealt with by a syntax checking tool specifically for that, language. That was one, idea I was thinking about. The other thing was how did you classify these novices and experts, right? You said novice Python programmer versus an expert Python programmer, but maybe the novice Python programmer has other, language experience, or how did it all play out? Could you speak a bit more to that, please?
All right. Since we're out of time, I'll be super quick. I love your first point, and I'll try to address it in the chat. And then just to address your second, since it's more numeric, we said someone was a professional software developer if they had 3 or more years of programming experience, and for a Python familiar expert, greater than 1 year of Python. A non-Python familiar expert would have 3 years of programming experience, but less Python. And we acknowledge that that's not what an expert would be called in industry. But right. A, we're searching from an academic perspective, and B, we're looking more at how novices would search on Stack Overflow, and even 2 or 3 years we thought would show a difference compared to 0 or 1, and that we did find that empirically in practice. So 3 years general, 1 year specific. I'll do the rest in the chat.
Great, thank you very much.
Yeah, I have a question for you, Bhuvana. Unless someone has a question for Bhuvana, do we have a question from the participant for Bhuvana? No? Otherwise, Bhuvana, for some of us...
Go ahead and address the question that came to me.
Yes,
I think that's the next one in line there.
Yes.
Cecile, you'd asked me about the difference between the control group and treatment group, as to whether the peer instruction intervention was the only difference. Yes, it was the same instructor who taught both courses. We utilize the exact same content and the exact same lecture materials. So speaking of peer instruction in general, just to introduce the idea a little bit, it's an active learning, pedagogical approach where students are introduced to the concept using some required readings. They come a little bit prepared to class to begin with, unlike a regular lecture. And then they have, one or two peer instruction cycles during the class, which typically involve them being quizzed midway through the class on whatever they were introduced to, a little bit, a mini lecture. And then we ask them a question. We call this an initial vote. To take the initial vote in real time and quiz and see how many of those students got it right, something relevant. And then if it didn't fall within a certain threshold, you allow them to discuss it in groups of 3 or 4 people, and maybe perhaps convince your group mates that, hey, what you chose was wrong. Maybe what I chose was right. Oh no, maybe I made a mistake. Let's get back to it. And then you give them a chance to vote again, the second vote, and then you eventually the instructor gives out the correct answer and then moves on with the next mini lecture. And this is an entire cycle. This is pretty much how peer instruction works. So we had these kinds of mini peer lectures followed by peer instruction cycles incorporated in the unit testing, integration testing, and CI lecture sessions. And that's how we came up with our intervention. The roots for peer instruction have been around since the early 80s in physics, and it's been widely used in other STEM disciplines. And in CS, I think it's been around for at least 20 years now.
Okay, thank you so much.
Happy to answer more questions if you had any.
Yes. Well, maybe we should move on to some other papers as well, and maybe rotate if we have more questions. So we have the next paper is a question maybe for Quang. So do we have anyone who would like to ask a question for Quang / Ni on the screen?
Oh, and before I go, Carl, I think you and I share an advisor. Elbaum was my master's thesis advisor 20 years ago at UNL.
Definitely.
We do. He's the best. I agree.
No.
He's amazing. Yes, I do have a different PhD advisor now, so he's the best too. But Dr. Elbaum is absolutely fantastic. Yeah.
So any question? I see, like Carl, for instance, you have a question for Quang. Do you want to go ahead?
Yeah, sure. So I pointed out how I thought your tool would be invaluable for students, but I was curious. I was thinking about kind of how much manual input needs to be put in this tool, because I imagine that this tool will become out of date very quickly, just how the times are moving with, and how much is manual versus how much is just pulled automatically, and can that be rectified if it is manual at the moment?
That was the main concern when we beginning to design system as well. So for the first point, how is it invaluable for new students? Actually, we have 3 kinds of recommendations we provide to students. Actually, if if a new student, they don't have any career interest or the career objective yet, our system will recommend the most optimal career path, which is the most suitable with their past courses or their current skill set. So, and for the next point is for the out-of-date data point. So that is the main concern, because for the job posting data, you can see that it could be expired like after 7 days or a few weeks or after a few months, depending on the recruiting side or depending on the company. So to address that point, we have the automatic scrapper pod to connect those data with the considered update time period. So for example, for the job posting data, our scrapping pods automatically runs every 3 days. And for the university courses and the online learning platform, they tend to be more consistent and change only when the semester of the university ends. And for the online learning material, actually, there were some legendary courses that could last for decades. So for those two data, we actually have the update period for every month. Oh, and for the manual input and automatic scrapping coverage. So what we manual input is the career objective that we define in the software engineering and the IT industry. For example, the career path should be machine learning engineer, front-end developer, back-end developer, Android developer, and the iOS developer. So currently in our system, there is 12 career paths. So.
Okay. Does that answer your question, Carl?
Thank you so much.
Okay, very good. Maybe we should rotate and ask a question to O. And we have, who wants to ask a question to O? O slash, his full name is Ang Lee O.
Yeah.
So we have, for instance, Wesley and Carl have question for him. Do you
Shall I
want to
just
go
quickly
ahead, one
raise-
of you?
I'm happy to ask mine.
Yeah.
I
Okay.
quite liked your presentation, and these days, or especially recently with like COVID in our neck of the woods, a lot of our lectures end up being recorded anyway, and then students, maybe if they don't feel comfortable coming into class, they'll watch everything remotely, often, as you hinted at, 1.5x speed, break my heart. But I'm curious, we may end up with videos that aren't created using your tool, either because they're legacy videos, or maybe I start using it in 2 semesters, but can't move fast enough to move it in 1 semester. Are there lessons learned from your study, maybe about things I should do if I'm being recorded even without your tool, or resources I should make available to students that would help students who are treating a lecture video as a tutorial, even if it wasn't recorded with your system?
Yeah, that's a very good question. So I think I have 2 points I can address on this. One is, even with this interactive environment that we have, we also discover that we're also quite uncertain whether we should be things like showing face onto the video itself. We actually sort of look into the existing literature. There's not really a agreement on whether showing a face by the authors or not would really help in the learning experiences. And we decided to test this hypothesis that we don't display at all, but we ask the students and the authors what do they feel. So the evaluation finding shows that they're actually also quite spread out. So it's not really very clear that they want to see the author's face or they do not want to see. So we still, I would suppose that there's not really a good advantage or good learning experiences if you really show the face. So we still continue with the no face. Okay, so the other one would be more on the UI UX part. I think the speed up is one important learning that we have, because the students, the 84 students that we survey on whether they really like this platform, over 70% like it, but we realized about 20% of them did not like it because there's no speed up. So the comments is very clear. The speed up, they wanted the 1.5 2x speed up. So it actually relates to us very well that we need to improve on the UI UX, even if compared to whether you are using a traditional video or using this environment. So UI UX is still very important. Okay. Thank you.
Okay, any other question for O? Or should we move? I think we should maybe move to Carl now. So do we have question for Carl?
Sorry, do you want me to address those questions in the chat? There are 2 questions.
So let's just rotate, make sure that everyone gets at least 1 question, and then we'll see if we have time for more. So maybe, do we have someone who would like to ask a question to Carl? Otherwise, I have a question for you. Maybe I can ask my question. So from my understanding is that developing one of the main challenge is the integration between hardware and software, with often we see the software teams waiting for the hardware to be ready so they can actually test the software on the real hardware. And so do you address that at all in your course, and also the fact that their life cycles are very different between developing hardware and software, with software even in a company, an organization like NASA
for
being...
Wesley. I was wondering, how difficult was it for you to get the institutional, let me.
Yes, so even at a company like NASA, organization like NASA, I know for a fact that some software teams on some robotic projects are using Scrum, which is very different from what the hardware system is using. So do you address that challenge at all?
So yeah, thank you. That's a very good question. Before I start, I'm going to mention that two co-authors here, Trey and Mariel, and if they think I'm doing a terrible job, feel free to jump in and throw in your what you say. But
you're doing great.
I think
I'm sure you're doing great.
The two, yes, you're correct. As anyone that's worked with a hardware system knows that they'll program something and have it running on their computer, and then they'll put it on a piece of hardware, and it will do a completely different thing. And it's this kind of interaction between the hardware and software. So you are right that a lot of the issues that arise are due to this. So I'm going to answer the question is, do we tackle that in this course kind of in two steps? Well, first, this course is relatively new. And so unfortunately, like all of us have been doing at the moment, we've been teaching it during COVID, which is all remote. So unfortunately, we weren't able to give them actual physical systems. And on that point, we have, and it was originally planned that the course would kind of transition from the simulation environment to a physical system so that they can, well, one, experience this change and how do you handle it and how we can teach them how to handle it. But unfortunately, we weren't able to do that. But I think this on the second part, we wanted to give them that kind of experience. And in order to do that, we focused kind of on these hardware abstractions. So for example, sensors are noisy. And one of our lectures and labs, actually, we take the sensor that they were given, and then, up to those points, it's been working perfectly as it does in simulation. And we simulate noise in the sensor to show, and then we take kind of their previous code, because we try to do a lot of reuse during this whole course. And we say, okay, well, take the code you develop now, run it with this new sensor noise, and they can then watch it, catastrophically destroy itself, in some sense, like it would in the real world. And then we teach them ways to overcome the sensor noise, using software engineering principles, and how do you handle this? And that's how we kind of simulated it during COVID times. I hope that answered your question.
Yes, it does. Absolutely. Thank you so much. Bhuvana, you had a question if you want to go ahead. I think Bhuvana has challenges here.
Yeah, the technical difficulties, but I can see her question in the chat if it's the most recent one. She's asking how difficult it was to obtain institutional review board or ethics board approval for utilizing these 1-hour recordings in our research. And minor wrinkles, but not too bad. In our neck of the woods, sometimes a human study is approved, and sometimes it's exempted from further review if it doesn't necessarily look, that dangerous. And this study did end up actually being exempted, but there was a bit of back and forth with the IRB about certain details, things like the consent form, how we were throwing away data after we recorded it. For example, we might keep information about participant identity in order to compensate them, store it separately, and then remove it, making sure that later when we end up with these video files or whatnot, that they don't have any identifying information. Some of that was best effort, but there may also have been instructions to people taking the survey to, don't have your other tabs open in your browser, or this sort of thing, try to minimize this sort of information. Ultimately, the students who are participating sort of consented to the recording activity. And kind of a related question is, do we think that put a damper on recruitment? Would that have a chilling effect? Maybe people are concerned about their privacy. And it could have. In our experience, often the time and the compensation matter more. We think that if the study had taken more than an hour, we would likely have lost more people. But the particular activity that's happening during the hour, we haven't found to be as much of a consideration. So some back and forth, but over the course of a few weeks, exempted from further IRB review, with careful attention to throwing away identifying information and preemptively encouraging it not to be there.
Very good. I like the fact that we have too many questions and not enough time. It's a good sign for a great discussion, but we're getting toward the end of the session. And so I'm going to ask the last question to all our presenters. So if there is one thing you want the audience to remember from your paper, what will that be? And you have about 30 seconds to address that. And we'll start with either Madeline, who is here, or Wesley. Madeline, you want to go ahead maybe, or are you ready, or should we have Wesley do that?
Sure, I can go ahead.
Yes.
Thanks, Wes, for handling the Q&A. I wish I could be in two places at once, but it was not possible. But yeah, the one thing that I would say to take away from our study is that searching for things on Stack Overflow is hard. And if you don't already do it in your own courses or your own institution, it may be worth looking into explicitly teaching how to search for things online. I know some courses like my own almost discourage that. They're like, hey, that's cheating. If you're looking up information online, like you shouldn't do that. It should all be like from your own sort of knowledge. But I think once we're more experienced developers, we do look things up online. And I think integrating that into the curriculum could really help students.
Very good. Thank you. Bhuvana, you're next. 30 seconds.